Again, as I was kind of prefacing before we got into this, we're going to be in linear mode for the first part of this cycle, and then we'll start growing into some other things and their applications as we go. So, as usual, we'll start kind of simple and build our way back, just because it may have been a little while since we've seen some of this stuff. So, linear relations occur when you can take the points from something, you make a straight line. I mean, linear is kind of got the word line right in it. So they can be represented by an equation, but that equation can take on several forms. So we're going to talk about the forms a little bit today, where they come from, and a little bit of that, and we'll go from there. So, linear equations are often written in standard form. Now, this is a little more interesting. We're so used to slope-intercept form that sometimes we forget some of the things with standard. Standard form, x and y are together on the same side. The number's on the other side. So there's one difference from slope-intercept. The other one is this. A, B, and C are all integers, which is just a non-direct way of saying we can't have fractions here. If you see a fraction in something, we got to do something to take care of it. Multiply through by a number, whatever that happens to be. A has to be greater than 1, which means A has to be positive. That's the two main things. The GCF being 1, that's just going to come in with the fractions part. So no fractions, the A value has to be positive. Those are the two rules that we got to keep straight. And so, if something's in standard form, or we're supposed to get it to standard form, usually that means there's something wrong. And it could be something very slight. Because you look at this, you're like, well, x and y are together, and they're all whole numbers. Oh. But this has to be positive. So there's a couple of ways we could fix that. One way would be to just divide everything by -1. That's going to make my A value, the number in front of x, positive. But it will change the signs on the rest. But I don't care. Because the rule just says this value has to be positive. Now it is. And now I'm good. So that might be all I need to do. Sometimes it can get a little more complex. So I'm going to start asking for a little bit of help here as we get into some of these next ones. So number 2, I see a few directions we could go. Any ideas on what you might want to try first? We need x and y on the same side. Minus 2x. I'm in for this. So if I do that, some of you again may be like, Hardy, why didn't we just put y minus 2x? That seems easier. Again, remember, x then y. So we want to make sure of that. So the question is, are we good? Are we done?
No!
Well, hey!
It's a negative in front of the 2!
Let's go. The people there are like, dang, they're like excited in that class. Hey, they are. That's good. We like excitement. It is Monday morning. We gotta kick it into gear here a little bit. That's a good way to do it. And perfectly correct on top of it. Gotta make sure that x is positive. That is 100% for sure. Nice. So you start to see with some of these, some of the ways we can make this go and go a little bit easier. Now I don't want to bust you through all of these, so let's think this through. Oh, we all see the elephant in the room, right? Yeah. Number 5. Oh dear. Okay. Yuck.
First, let's go with a fraction.
I agree. So how are we going to do that?
Multiply something.
Not a bad idea. If we multiply the denominators together, so that would give me 12. So let's multiply all the way through here by 12. Even that one that's not a fraction, let's do it. So if you're not sure, when you distribute, just a kind of a note for reference, if you multiply by the numerator and divide by the denominator, that's going to take care of it. So like 12 times 3 is 36. Divided by 4 is 9. But if you're like, not sure I'm going to remember that long term, you always can go straight to the calculator and just do 12 times 3/4. Just put the 3/4 in parentheses, and you'll get the 9. So let's see here. 12 times 1 is 12, divided by 3 is 4. Don't lose your y. And 12 times 1 is 12. All right, let's check this out again. X and y are on a side together. Good. No more fractions. Good.
I don't think we need to do anything, honestly.
I don't either. One step, we're out. All right, one last one of these, then we'll change up forms here. Ooh. I don't like that.
Me neither.
Let's take care of that.
Let's multiply.
So there, 1/6 of 6. Last I checked is 1. 6 times y. 6 times -2.
That equal sign should not be by the x.
Let's see. I don't know. It might not be in a minute. Because you're right. We got to fix up some things here still. Because, yeah, x can't be on a side by itself. So how are we going to get x and y back together?
Minus 6y?
Minus the 6y. Now are we okay?
Yeah.
Yeah. Because again, it's okay if this value is negative. The only one we got to keep an eye on is that number in front of x. It's positive. X and y are together. No more fractions. We're okay. Bless you. So what you're going to find out down the road is standard form is a very nice form to be able to get stuff in if we're doing application stuff. It will make things easier. So just a tool in the toolbox to help us. But what are we really used to? We're used to this. Slope-intercept form. I'm not a fan of the or thing, so I'm going to ignore the or here. We are good old y equals mx plus b. And when we're in this form, those are the two values that we are focused on. Whether we're graphing, whether we're doing an application, whatever that happens to be. Because the M, it is like just working its way around here, up and down. Blessings out there, blessings. Okay, and B is going to be my y-intercept. So, in order to use slope-intercept well, okay, slope-intercept form, we've got to make sure that we understand the slope part of it especially, because it's a rate of change. So like you can use that in business, you know, you can have, I don't know, a number of units you sell per hour, per day, per month, and start to calculate, you know, what your profit or loss, hopefully not, is going to be as you move on. So there are going to be, well actually, oh my gosh, you can tell it's the morning. I got 4 blanks here and I write 3 types of slope. There's 4 actually. So when we're doing slope, we got positive and negative. Those are the two that we deal with most often. And so here's the thing to remember with those. If you're just kind of visualizing and trying to figure out here. Positive slope is going to go up to the right. So as I look from left to right, it's on a positive, it's upward, it's thinking well, positive thoughts here. We're going to keep going up and getting better. Negative, we're going to be going down as we go to the right. Everything we always think left to right, just like when we read or anything else like that. But now, let's think a little bit here. What other types of slope could there be besides positive and negative?
Positive?
Straight line.
Straight lines, okay. Okay, so now let's see. So if we went straight line that way,
Parallel to y, parallel to x.
and we went parallel with those, so now here comes the question. What are the slopes when they go that direction?
The horizontal one is 0, and the vertical one is not defined.
Okay, not defined, undefined. That's absolutely right. So I want to add a small piece in here with this because we're going to deal with slope itself and its formula as we go too. When you're looking at equations with these, okay, positive and negative will look just like this. There'll be y equals, there'll be some number x, and usually there'll be a y-intercept. With undefined and zero, we don't get that. With undefined and zero, we're just going to get x equals and some number, like if that, let's say, was 3, it'd be x equals 3. And if we get it with 0, we're just going to get y equals and a number. Like if that was 2, it'd be y equals 2. You're not going to have y and x in those situations, like we did with just a positive or negative slope, typically. So there's still a couple of things that can give us a little hiccup if we're not careful when we're going through these. Even though we've been seeing it for a while, it still can kind of throw us for a twist. So I think that's it on the thing today. Let me peek ahead. Yeah, okay, not bad. Not bad. Because I got to give you guys more info here on some things here in a sec, but we'll do that when we're done getting situated here. Okay. Practice. I want to do a couple things over here because there's one thing that I didn't put over there that I should have. You're like, Artie, you want us to find slope and we didn't talk about how the heck to find slope. What is wrong with you? That's a good question. Not one that I have a good answer for. So let's take a moment here. I still, to this day, I've been teaching math for 27 years, and as a student of it many years before then, and I still can't figure out why they decided to use M for slope. They must have already used up S and didn't want to change something, but whatever works for them. So what we're going to do here is we are going to, and I always tell people, but you might not need to do this. I don't know. I like to label my points. Just because it seems to make it easier where I don't like put the X's on top, or I accidentally use one Y and one X when I'm doing it. I see that happen quite more often than I would think. And so when we're doing these, if I label everything, now it's literally just plug it and go. It's like, all right, so Y2 minus Y1 and X2 minus X1. And if, now again, we don't want to do decimals, okay? No decimaling here. That would not be helpful for us. So it's like, well, it's 5 halves already. Okay, 5 halves it is. That's fine. So we're going to simplify some of those. However, I do want to do one more. Not because I don't think y'all can do slope, but just because one little detail that I even find myself getting thrown off by. And that is, what happens when I get into a situation? Did I really just mark that X2? I did. You see why I'm having you guys do this stuff, because I'm telling you, I'm a goofball. Especially in the morning. I know.
We have tomorrow off.
Yeah.
I know.
Why can't I just both days off?
We're going to be
Both
so
days
messed
at
up.
school. We don't need both.
I'm telling you.
Teachers need to practice only voting next time.
I'm telling you. I did, just as a reference. But yeah, I agree with you. It's like we need to figure out a way around this. So -1 minus 4, okay, that's normal. 3 minus -2. Got to make sure that minus and negative becomes plus. It doesn't become 3 plus -2. It got to be careful because that can mess us up otherwise. And if we can simplify the fraction when we get to the end, we absolutely should. If you want to leave it as a fraction, you can. If you just want to leave it as a whole number, if it comes out nice, that's okay too. So this is more about attention to detail, to make sure we're getting our signs right, and in my case, that we're labeling the points correctly. So again, not too big of a deal. here's the other twist. The other twist that can come in is, well, what if they, bless you, throw in just a bunch of points at us? You're like, what's up with all this stuff? All this is, these are coordinate points. They're just in a chart form. And so you're like, well, I don't need 4 points for slope. I only need 2. Oops. You can pick any 2, and you're going to get the same answer at the end. It does not matter. So whether you pick the first 2, the last 2, these 2, or any combination thereof. So let's just say, I don't know, for fun, let's go with the middle 2 here. So I'm like, all right, x1, x2. Again, totally up to you if you want to do the labeling like this, but it has saved me many a time. So y2 minus y1, x2 minus x1. Even got answers at the bottom to check. How about it? So again, totally a pick of yours. As long as you know what you're doing is linear, you can do this. We'll get to a point where they won't be, but for now, we're basically telling you that they are, so you won't have to worry about that. Good question. So as long as I have first the y's on top and the x's in the bottom, but even then, so would it matter if I did, you know, like this minus this instead or something? As long as I'm consistent, it doesn't. So like if I use this y first and I do these 2, I got to use this x first when I use those. Yeah, it's got to be in the same order with the points. Yeah, I can't flip those around or my signs are going to get messed up. Good question. Another reason I like to label them, just to be sure that I keep them in the same order.
You know, I have a Bucky's blanket that I got from a friend that lives in Texas.
Nice. They have a lot of Bucky's in Texas. Lot of Bucky's.
Here.
Not any around here yet. Yet.
Yet?
Still hopeful. Still hopeful.
It's very good. I use it as a type of weighted blanket on my bed. I have 2 weighted blankets. One has a hole in it because I dropped some of a bubble gum on
Oh
it,
dear.
and it was stuck.
Oh dear.
So we had to cut it off.
Oh. I gotta check one thing before I say anything else. Okay.
Anyway, smash time. So,
That's all right. We like kind of just chatting as we go along here too. All right, find the slope. I flipped over to page 2. Find the slope of the given graph line. Simplify fractions as possible, no decimals. Now, we know a couple of things already before we get started. For instance, on 17, I know that my slope is going to be negative because it goes down as it's going to the right. Whereas, like, let's say number 18, I know right away that that slope is positive because it's going up to the right. So how do I figure out the slope? I need to find, when I'm looking at these pictures, a couple of dots anywhere that are going through what I like to call the crosshairs of the graph. Like you're looking for where it crosses, like right in the middle of the old bullseye there. There'll usually be at least 2. There may be more. But you don't want to pick ones that are like in between or in the middle because those are really hard to count. If I can find the other ones, then it's kind of easy to say like, all right, I went down 1 and I went 1, 2, 3, 4, 5, 6 to the right. Did I do that right? 1, 2. Yep. And to the right is positive. So my slope would be negative 1 over 6, which makes sense. It's going down to the right. It should be negative. But sometimes my points will be really easy to find. Because I look at like 18 and I'm like, well, I got lots of choices here because there's lots of dots going through with those. And I can pick any 2 I want. They don't have to be right next to each other. I could use this one and this one if I wanted to. I'm not going to because I like to keep it really simple.
I think it's just 1 over 1.
I think it's just 1 over 1 as well. And we're good there. So we're just kind of taking in some applications as we go with these. The last piece of the puzzle here, and again, I don't care if you go into evens, odds, something like that with this, because there's a lot of problems in this area. This is kind of, you're like, wait, rate of change. Okay, that rate of
What
change.
number
Okay, let's go back and look at 19 first. Let's come back.
it says M is
Oh, find the measure of CBD. Oh, dear. Okay, so, first question. What's that little square mean?
Right angle.
Right angle, which is how many degrees?
90.
90. So that tells me if this whole thing equals 90 degrees, these two angles right here,
are 45.
well, I can't guarantee that. Now, if there were little markings here to say they were equal or congruent, I could say that. But I can say that if I take the pink angle and add it to my blue angle, together they're going to equal 90 degrees. And I can solve that equation for x to figure out what each angle would be. But I'm not sure if they're going to be equal or not. Let's see here. Let's find out if they're going to be equal. Add that 9 over. Divide by 11. Okay. So x is 9, but that's not the answer. Because at first I started looking at my answers, I'm like, what the heck, Hardy? 9 is not the answers, but that's not what it's asking for. It said find angle CBD. Well, there's angle CBD, so I need to plug in that 9 for the x there. And I think, yeah, we're not going to end up with 245s this time. CBD is 56, and I could still figure out ABD pretty easy from that too. But this is where some things, we just kind of like to bring some review back with stuff now. Because you never know when all this stuff's going to come back together when we get towards the end with our last project. Okay. Last thing to play. Last thing to play. Page 3 is going to be where we're stopping here anyway. All right, find the rate of change. Okay, rate of change is just a really fancy way of saying slope for each of the following. And I'm going to try and help out here with some because it looks like 2 of my graphs did not print out the numbers for poo with this. So let's see if we can fix that up some. Basically what's happening is every other line is going by 8. So if you're counting every line, it'd be 4. It's like 4, 8, 12, 16, 20, 24. 1, 2, 3, 4. That actually I can read along the bottom. Over with these guys, all right, I got to look a little deeper. This is going by 25s. So let me kind of update these a little bit. I got to start learning to just tell them at the copy room they need to crank up the darkness on some of these things. And so you're like, okay, well, how am I going to find the slope? Well, there are some points on there for me to use. So like, for instance, here, I got x is 1 and y is 8. That would be a good one to use. And then here, I got x is 2 and y is 16. I could use the slope formula. Since I have a graph, I could try to count how many up and over, but be careful because, again, it's not 1 every line that I'm doing. So I'd have to be a little more cautious if I wasn't just going to use the numbers in the slope formula. So I'd probably use my slope formula instead, just so I don't get sucked into thinking it's like, oh, it's up 1 and over 1. But it's not in this case. So that kind of puts us on